Good evening, everybody. In our last episode, we set up the Unity engine and demoed some ML agents, machine learning stuff, and some of the examples that come with ML agents. In this episode, we're not going to do any of the setup, so if you don't know how to do it, you should go watch that episode first and then come back here. In this episode, we're going to try our best to set up a cat and mouse, cat chasing a mouse environment. I've now built it several times, and I know it works when it works, but I've been having a lot of Unity issues where, for example, collision detection just stops happening, or the ML agents goes away. So hopefully this works, and if it doesn't, I'm gonna give up because it's I've been doing this for days now. It's like I'm literally on my 100th and something version of this. It's ludicrous. I'm just very stubborn. I really want this video. So some comments on Unity 3D in Linux. It's not there yet. They've come a long way. I used it a couple of times in the past, but I mean, obviously the developers don't have a lot of support. The people doing it. I mean, it's not even available officially for download. I think it's an alpha release, so it's fine. It's fine. It's just not. I probably shouldn't have started this project yet because it's not there. Okay, so the first thing you do is you're gonna go grab the. Oh, look at this. See, Windows 95. You're gonna go to where you installed the Unity SDK. Go to the assets folder, grab gizmos and ML agents. Then we're gonna go back to the root of your new project in the assets folder, and you're gonna dump ML agents and gizmos. It'll take a sec to import. Sometimes it asks you to convert scripts. I don't know which way to go with this. Sometimes I do it, sometimes I don't. I made a backup go ahead and it didn't work, so this time I'm gonna say no thanks. Maybe I should git clone the repo. Maybe there's a problem with the repo. Dun dun dun. Or we'll get lucky and it just works this time. So a lot of stuff has to be imported because it's all the example files and all the other stuff. Those are really good references, by the way. Some of the behavior is confusing the first time you use it, so it's really good. So if it worked, what is this? Could not load game object. Okay, I don't know. It seems to have worked though, because it says ML agents up here, so that's how you know it worked. We're going to add a learning brain, cat brain. Actually, it's called cat brain learn. Okay. And in the actual tutorial on the website, they make you add a player brain, but we're not going to use that, so we just won't add it. I'm going to jump ahead to the section where I can test if the collision is working, because I don't want to move forward with this tutorial if the collision isn't working. So forgive me while I jump way ahead and do a bunch of stuff. I'm going to add a ground. And then I'm going to add two objects. The first object is a sphere. This will be our mouse. Okay. And we'll make him smaller. 0.3, 0.3, 0.3. And we'll give him... Our mouse needs a couple of stuff. It needs a... Is that the light? Get out of here. Our mouse needs... So it's already got a sphere collider. We need to add a rigid body and another sphere collider. The reason we need both of these is because one of the sphere colliders is for physics, and the other one we're going to use as a trigger. We're going to use it right here, is trigger. This is a function that I need to do... I can use the collision detection, but it seems to work most consistently. However, recently it's not been working, so I may need to revisit this. So... yeah, we're going to do that, and then we're going to add our cat. Our cat is also a sphere. If you guys studied any engineering or physics, you know, approximate the cat as a sphere. Should make sense to you. Cat. And we need to give the cat a rigid body as well. And we're going to add a script to the cat called agent. This all comes later, normally, but again, I'm jumping the gun here because I want to test that the... collision is going to work. So we're going to write a little script now, our agent script. We're not going to import any of this stuff just yet. Actually, let's do that. Let's import some stuff using ML agents. And then we're going to import the, agent.agent, can't have that. I think that's going to cause a problem. We'll find out. Yeah, we can't have the script be named agent. That causes problems. So let's fix that right off the bat. Delete. We'll call him cat agent instead. You get naming collision issues with the... Let's just get rid of this. Boom. Add a new script, and we'll call it cat agent. I don't really know why it's a problem. It has to do with the namespace. You can't have the namespace and the inherited space be the same thing. I guess that makes perfect sense. I don't know. So, let's get ourselves a new window. And open up, oh, cat agent. We are going to, using ML agents, agent, and now so there we go, different class and different thing, okay? We're going to public, actually just do this up here. We need the transformer, the cat, or the mouse, because we're going to track the mouse's position and the cat's position from inside this script. So we'll just grab that, mouse bond, okay? And that should be it. The other thing we're going to do is implement private, what the hell is it called? Private void on trigger enter collider mouse. Just assuming it works. Print. This is definitely working. This is the thing that has been failing on me randomly. There is a GitHub error about it, so if you do come across it, I don't know, go check out the GitHub. Personally, if you come across it, just give up, start over. I couldn't get it to fix. If you can get it to fix, please tell me how, because the amount of projects I've had to start over, it's too many. Okay, so we're gonna watch the console. Clear. And we're gonna drop this guy. Boom. This is definitely working. Okay, so we can progress because we have physics interactions working. Great. That means this trigger's working, okay? Actually, let's test one more thing. So mouse, we're actually going to give the mouse a target, a name, because we want to specifically mention that if it collides with the mouse tag, that's what we want. That's what we want. If mouse.tag equals target, print we found the right object. We will delete all of these debugging script or print statements because everything you print at the console slows down the actual training. Come on, come on, come on. Boom! Perfect. Everything's great. Okay? So we can proceed. Let's save this. Back to the start of the project. We are going to make this ball, or sphere cat, chase this sphere mouse around this grass. Okay? That's it. It's real straightforward. It's also pretty cool when it works. And at the end of that, we're going to do some... That horn was going off earlier. That guy's car is either constantly under assault or he thinks it's valuable. Can you guys hear that? Ridiculous. Yeah, so this will be cat. We'll make the cat a tabby cat. Yay. Yay, tabby cat. Boom. And we're going to make the mouse purple because purple is the best color. Is it? It's a good color. Boom. Okay. Where's our camera? What's our camera looking at? Do that. And rotate her down. And then I guess move it forward. That's a pretty good view. Okay, so other stuff we need to add. We need to create an empty object and call it Academy, okay? Then on that object, we're going to create a script, which we're going to call Cat Academy. again, so we don't have name collision, because we're going to inherit the academy from MLAgents as soon as it's ready. This stuff you'd normally do at the start, but again, I wanted to make sure that everything was working. So this is going to become academy. We're actually going to delete all these because the academy doesn't have a lot. You could re-implement, or sorry, override stuff if you wanted, but you don't need to, because this handles everything you need right now. I'll show you what it does actually. Boop 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 boop. How is everybody anyways? It's been a while, isn't it? I've been looking for a job. You think that would give me more free time to make videos, but nope. It's because I'm looking hard. Okay, so when you click on Academy, we get this script expanded out here to show a broadcast hub. We're going to click Add New there. Now it says Brains. So we created a brain earlier, the cat brain learn. Drag that on there. Control, when you check control, that's when you're training, and you uncheck it when you're watching, okay? So we'll just check it for now so we don't forget later. There's nothing in training config or inference config that we want to mess with right now. If you want to see the training slow down way slow, and so you can like watch what's actually happening, you drag that down to like 1, okay? You can also set a max steps. We'll do that in the program. We won't worry about it here. So that's all you got to do for this. Now to cat, we have our, I forgot to do that. Let's do that. Let's make sure. So you basically, on the cat, you're going to drag in the mouse because we want to know the position of the mouse, and this is the way that Unity connects them. It's kind of neat. I like it. Let's make sure that he's still saying boop. Cool. That worked, right? Pop. Okay, great. I'm just complaining about some stuff, though. The computer... Yeah, it's because I put on training and ran it. Okay. So that's all this. This one also wants a brain, so go to your project and drag the brain up onto that guy as well. There's actually 2 types of observations available to you. You can do vector observations, which will be floating points in an array, which you could submit. Or you can do a visual observation. So if you did a visual observation, that would be like images of the game environment. And to do that, you'd have to add a camera. You could just use the camera that's right here, but I'm not using that, so I'm not going to do that, but I just figured you should know. If you double-click on the learning brain, cat brain learn, you can see some stuff. Vector observations, the space. This is how many observation floats in a list or an array you're going to submit. We are going to submit the X, Y, and Z coordinates of our mouse and our cat, so that'll be 6 for us. And then, not 16, just 6. And then we're going to, this is your vector action. These are the outputs from the network. We're going to output just 2 vectors, or 2 floating points to create a 2D vector, the X and the Z coordinates, so that our cat can orient itself towards the mouse, and then we'll just apply a velocity in that direction. So we need 2, okay? And we actually don't want discrete, we want continuous. Discrete is if you only want, say you have 10 possible actions and you only ever want 1 at a time, you can pick discrete. If you pick continuous, it'll give you a percentage, or it'll give you a floating point for 10. So, you know, like if it learns that it should always be the 5 when it's doing a certain thing, then it'll mostly give you 5, but it'll give you small percentages of the other ones. And sometimes that's, you know, a problem. But in this case, we need 2 values. We need the X and the Z value to create a vector. So we want an output space of 2. Okay, so in 6, out 2. I'll show you where that comes into it in a minute. Okay, we got our cat, we got our mouse, we got our academy, we got our brain. Let's make sure that this is still working. I seriously, I've gone to the complete end of this tutorial so many times, only to find out that the collision detection has stopped working for some incredible reason, and it's infuriating because I can't use that video, right? Because it's me setting it up, and I don't know if I've screwed something up along the way or what. I can't upload that. It's been very sad. Okay. So now let's get right, and we're not going to do this one anymore. So we've inherited agent from MLAgents, and there's a bunch of pre-made methods in there, and we're going to override some of them. So the first one we're going to override is the agent reset, which gets called every time done happens. Done is the state that is when your whatever conditions you've set to reset your environment occur. So like if when we were training Sonic, when he dies, that's when it's done. Or when he finishes the level, that's when it's done. It's the end of the training episode. Okay, so private override void. This is also an inheritance too, guys. Inheritance and overriding of methods, which is some cool programming stuff. I made a video on that in Python once, but this is also how you do it in C#. So, you know, that's fun. Learning, yay! When our the way we're going to set this up is our cat and our mouse are going to randomly start at random positions on the grass between 1 and 10, which is the I don't know if I actually moved it to 1 and 10 yet. I didn't. Boom, boom. Okay, so now zoom out. So this is 0, 0, and this is 10, 10. Okay, so our mouse and cat are going to randomly start all over the place on this board, and then the cat's going to try and get the mouse, and that's how he's going to learn what he's doing. He's going to be rewarded for catching the mouse and for getting closer to the mouse. He's going to be punished for taking a long time or for falling off the grass. Yeah, and that's it. That's our whole training method. Okay, I do have a version of this that works. So I guess at the end of the day, if I can't get this thing to play nice, I could always just show you the video of it working. But that seems relatively disingenuous, doesn't it? Who knows? Who knows things? Sorry, I just got to keep checking that it's going to keep printing out the... It worked! Okay. Pretty soon I'm not going to be able to check that, so I just, you know, I really want it to happen. Where are we now, guys? We are... yeah, so void start. We've got transform mouse bod. Oh, yeah, we also want to get the rigid body of of the cat bod. Cat bod rigid body. We'll grab that at the start. So cat bod equals get component rigid body. So this get component function grabs one of the components from your object. And we're going to, that's it, we're going to grab it at the start. Okay, nothing else. That's it. We're also going to set the standard reward for our training up here to 1. I'll get back to this later, but I'm not actually sure this is necessary, but I did do it and it did work, so we're gonna keep using it. Anything else we need? No. In agent, we're going to say this transform dot position is equal to new vector 3 random dot range 1 to 9 0.5 dot and then random. Okay, so what we've done here is we've said every time the agent is reset, move this object, and this script is connected to the cat, so that means the cat, this is the cat in this particular case, to a new position on the grass. We're going to do the same thing for the mouse, but in the mouse case, we don't actually have the rigid body, so we need to do get component rigid, what is it again? Rigid body of equal, nope, what am I doing? No, I'm drunk. Guys, we can just do a position. Position comes with transform. You don't need to worry. Just copy this because it's the same. This means that sometimes they'll be on top of each other, but it's fine. It doesn't matter. The other thing we're going to do is we're going to reset the cat's velocity to 0, because once he gets going and the agent resets, if we don't stop his velocity, he'll maintain his velocity even though he moves to a new position, and weird stuff will happen. So let's do a cat bod velocity equals new, nope, vector 3 0. Okay, and because, oh, this is where I do it, get component, I knew I did it here somewhere, rigid body velocity equals vector 3 dot 0. Okay, so we've zeroed both of them every time the agent resets. The next function you're going to override is called, it's not, this one's not, this is not a private function, it's a public function. Okay, guys, public override. Forgive me, the on trigger enter is private, that's the only one. So public override void. This one's called, what is this one called? Collect observations. Okay, this is where we grab the 6 variables we need for our network. So there's a method built into it called add vector OBS. With the visual ones, you don't actually need to do this. You just assign it to camera. But for the vector ones, you do need to tell it which vector it needs. So add vector OBS. We're going to say this transform dot position, and that's the cat's position, X, Y, and Z. And we're going to also go mouse bond transform dot position. This is the mouse's position. And then, so that's 6 things, right? That's X, Y, and Z, X, Y, and Z. And now we're going to implement the, oh, let's keep this here, actually, because this one probably happens. Now we're going to implement the action, what to do when we call, when we ask the network to make a decision on what it's looking at, okay? Agent action. This one gets a float or a list of floats or something like that. Let's find where it is. Yeah, it's an array of floats called vector action and a string called vector string. Okay, we're not actually going to use the vector string. I don't really know how it works right now, but we are going to use vector action. Vector action contains the two floats in the string from our brain. Let's go. Sorry, whenever you go back, it always takes a sec to load. So when we look at the cat brain, remember we took the 6 inputs, right? That's this right here, these 6. And then the vector action has our 2 outputs. And we're going to assign that to our cat's velocity. Okay, so cat moves equals vector 3.0. I'm just going to initialize a thing there called that. Cat moves.x. Since it's a vector 3, it has an x, y, and a z. We will say this is vector action 0. And cat moves.z equals vector action 1. All right? And then, pretty simply, we're going to say cat bod, not mod, velocity equals cat moves times 10. We'll say times 10 because if we don't, he'll move real slow. The output of vector action is -1 to +1, so the fastest he'd ever go is 1 unit of speed in the environment. So we're multiplying it by 10 just to get him to go faster, that's all. Okay, now we need some done conditions. Our first done condition is going to be, it's going to be several things, which I'm just going to copy and paste and read them out to you. So our first done condition is when he dies. Okay, so get step count is a method provided by by the Unity engine that, oh, maybe it's MLAgents, doesn't matter. This method counts the steps that the learning process has gone through. So when we get to 998 or just past 998, we're going to issue the done command. Okay, we're also going to add a reward of -1.0 float. Oh, the reason I keep putting F on everything is because when you just put a regular decimal place in, Unity thinks it's a double, but all of these ML agents and stuff, they seem to want floats, so you need to declare floats every single time. That's what the F is for. So once you call done, agent reset is going to get called. Okay, so this is actually the end of a learning episode. So basically, if he takes too long, die and subtract 1 from his score. Other reasons he's going to die is if he falls off the grass and goes down, or if he goes too far in the X on either the left or the right, negative or less than 0 or over greater than 0, and the same on the Z. Okay? So basically, if he falls off the grass or he takes too long, he's done and subtract a point. He did a bad job. Okay? That's our main done. We're also going to do some fancy stuff with distance, okay? Because the way this works right now, the cat gets rewarded for colliding with the oh, we haven't actually done that yet. So remember we wrote this collision statement up here if he connects with it, we found the right object. We're actually going to add a reward here of +1. Okay, that means he did really good. Right? Call done, because it's gonna end at that point and reset everything. But he did so good that we're gonna give him 1 because he actually caught the mouse. Okay, so that's when he does good. We'll leave that in for now just for debugging. So far it'll be done if he catches the mouse, or if he takes too long or falls off the edge, he loses. Additionally, I want to put in some calculations for. Actually, you know what? Let's just see if he's learning right now. With this, the way he is right now, let's see if he'll learn. This is the simpler mode, and it might help. So we saved that. We're going to go back into the environment, and we're going to look for something called decision interval. We're going to make the decision interval 10. Okay, so if it's 10, that means every 10 steps, ask the network for a decision on what to do, and then the network will provide us with the 2 floats for the X and the Z, and our cat will move in that direction. Okay. Mouse. Cat agent 24. What I call a mouse? Mouse bod. Forgive me. Did I get that everywhere else? Yeah, that might be confusing. Oh, here it is here too. Mouse bod. Jeez. Those ones are fine. That's fine. Okay. Good stuff. So we need a... this is my previous stuff. We need... So we just did the decision interval. We made it 10. We've got our mouse connected. This should work now. But... you know, it's been quite a pain in the butt up to this point, so I can't promise anything. We've sourced into our Unity environment that we did in the last episode. So if you don't know how to get to this, watch the last episode. We're going to go into the folder MLAgents because it has the config in it, and the command we like to use, which is MLAgents-learn config YAML, is already here. We'll call this cat and mouse 111 and train. Okay, so config.yaml here is something that you can find. Let's see if I've already recently opened it. I probably have. Okay, so config.yaml is in config.yaml, and the default trainer, the one we're going to try and use right now, is a PPO, and the only thing that I've changed from the git clone is the batch size is 10 and the buffer size is 100. They recommend you do this in the tutorial that this is based on. So, I don't know, do it. All of these settings change stuff. If you want to know what they do, you should probably read the original PPO paper, or you can do the Unity now offers some really cool reinforcement learning projects. So you can go check those out too. Not Unity, OpenAI. Anyways. Don't worry about this. Just use the default. Make it batch size 10, buffer size 100. Okay? Okay. So let's try now. Let's see what mistakes we've made. When you run this, it's going to ask you to push play inside the Unity environment. Boom. It's ready. Let's go. Oh, our camera's going to be off because I didn't adjust it. Boo. Whoops. Okay, so he's finding it. He's finding it. That's a good sign. That means that it's going to get some scores. We'll have to move the camera, but I just want to make sure that he's learning, okay? So every 1,000 steps, it'll tell us his score. So he's currently negative 4.324. If it's working, I expect that number to get smaller. And is it working? It is! Okay, so let's just adjust this camera. Actually, we'll just let it train, and we'll come back after it's done training and watch what we've done, okay? Oh, he's getting real good. Look at that. Okay, he's getting worse again. Let's see. So now we can watch to see what's happened. So first thing you do is go back to Academy and uncheck Control. Okay, and then we're going to go to our project folder. And remember, we're in Cat and Mouse 1111 for this one. The trained network, I'll show you, when you stop the thing, it makes a model in Models, Cat and Mouse, Cat Brain Learn, okay? So whatever you named yours, that's what we named. But It'll be in the root folder, MLAgents, models, cat and mouse 111, and you need this. Okay, we're going to copy this into our root folder of our project. So cat and mouse, we'll put it in assets, paste it right here. This is where all our scripts and objects are. Okay, so you see those things? And then we're going to go back to this, and we are going to find our brain. Where's our brain? And in our brain, there's this model. We're going to drag the new learned model in there. Okay? Now, when we push play, as long as this box is unchecked, the learned network will control our cat. I need to fix our camera. Let me fix the camera. That looks good, right? Okay, here we go. So not totally working yet. So remember, we don't have... The cat only knows that he succeeds when he accidentally collides with the mouse. He has no indication that... For example, we can make this more efficient if we include a distance calculation. Oh, there you go. So he got the mouse. He's just randomly moving around until he finds the mouse. This will work eventually. He'll train for a while and eventually find the thing, but I think we can make it quicker. Okay? So if you're satisfied, you can stop the video right now and move on. But I'm gonna add some more code to do some cooler stuff. Then we'll train him for a while longer, and then we'll do some even neater things. But you'll see the cat does eventually find the mouse. Right? It's working. Okay. Am I still recording? I am. Thank God. I'm just happy it's working, everybody, because it was not working. I've done this so many times today. Okay, so we're going to make a new variable. Actually, let's move one of our other variables down here. I like to keep all the variables in the same place. Whoops. Not there, guys. And we're going to make a variable called, it's a float, and we're going to call it old distance equals 0.0f. Actually, I think it should be the hypotenuse between, if you do 10 squared plus 10 squared hypotenuse, I think it's like 14.14. That's the distance across here, I think. I can't do math, though. If that's wrong, you know. Great. We're also going to declare distance, which is equal to 0.0f, okay? We're going to use those two variables in a second. In fact, we'll do it right here. So we want to reward our cat when we make a decision if he's closer to our mouse. That way he will learn to always run towards our mouse, okay? So we don't need to declare that. We'll do distance is equal to vector 3. Oh, no, actually, let's do the ABS because we don't want negative distance calculations. We don't care. We're going to say the closer to 0, the better. So every time if it's closer to 0, he gets a reward. We're going to use vector 3 because vector 3 has a distance calculation built into it. And we're going to say this. Actually, let's go with the mouse. Mouse bond dot transform dot position. And this transform dot position. So that's the distance between the cat and the mouse. Okay. Then let's do a little equation here, or a little if statement. If distance is less than old distance and reward of 0.1f. So not tons, but just a little bit, just a little encouragement to go in that direction. And then we're going to set the old distance to the new distance so that the next time he comes around and checks, it'll be like progressively better. Oh, that means we also, when we go to reset, we need to go old distance equals 0. Nope. What were we saying old distance was? 14.14 f, the furthest away he can be. So every time the agent is reset, we got to reset old distance. And then we're going to do one more thing. This may be too aggressive. This may break everything. But we're going to add a negative reward of negative 0.01 f. if he's not making progress. So every time we ask the network to give us a new velocity vector for our cat, if he's not closer to the mouse, subtract a small amount. This is to encourage him to quickly find the mouse. Okay? Who knows if it's going to work? Who knows? I know it works. It worked before. So that's what we're going to do to train our guy. So let's train him up. It's just got to load. Once it's loaded, we will go to the academy, enable control of the neural network. We're going to remove our previous one. Okay, just because I want to train him from scratch. We'll use the exact same training settings, and as soon as it says push play on the network, we'll be back when it's done training. Whoops, made a mistake. Line 63. 63, I forgot a comma. That is... Oop, forgot a bracket. You don't know how many times I do that. It's near constantly. If you wait too long after starting this, it'll time out. For example, it's probably going to time out on me here. Let's see if it times out. Oh, maybe I'll beat it. Nope, it timed out. Just the last possible second it timed out. So let's get that. So there, that's what a timeout looks like. You just restart it. Nothing happens. And go! Okay, so now our cat is learning to chase our mouse, I hope. He seems to be keeping his distance from him, which is not perfect. He already has a really good reward. -463, that's pretty good. Hopefully it goes positive and stays positive. We'll be back at the end of the training session. Oh yeah, he's doing good now. And I'll demo our cat and mouse neural network. Yay! I mean, I think he's done it. Let's give him one more. Yeah, he's doing good. Okay, so let's copy that network like we did before. What? So it's in MLAgents, models, cat and mouse. Make sure it's approximately the right time. You're not copying the wrong one. 549, that worked for me. Go back into your root folder and dump in your trained network. Override. Go into your environment, uncheck control, go to your brain. Where's your brain? And drag the, it's already on there, but if it's not, make sure it's on there. And then you can watch your cat chase your mouse. Yay. Get him. Jump. Get him. Exciting, eh? I mean, it's not really exciting. It's cool, though. Yeah, this one's not the smartest cookie. I'm going to now demo the one that I trained up the other night, that I let run overnight. So he's much smarter, but I don't have that much time right now. So let me just show you that one. That's how you do it. You can just train him for a really long time and everything will work. So there you go, guys. A custom Unity environment. Hopefully you have better luck with it than I did. I really struggled today. I truly did this so many times that I probably won't do another Unity environment for a while, just because it's such a fickle thing. Okay, so this is the one that I trained up myself. So this one's much better. I also have some cooler motion for the mouse. He runs in a circle and randomly darts around in different directions. And you'll see that the cat, the well-trained cat, adapts no problem. It's really cool, actually. Let's just make sure the academy is not set. Okay, here we go. See the mouse moving around, and the cat still gets him. Yeah, get him. So I didn't train him on a moving mouse. I trained him on a stationary mouse, randomly starting all over the place, and he still gets him. He totally handled this. You see him totally changing direction when the cat Sometimes he peeks at me. Yeah, look at that. He still gets it. That's cool, right? Okay. Okay, nobody thinks this is as cool as I do. Anyways, guys, if you have any questions, feel free to ask me. I know some stuff. I'm not a Unity expert, so if it's a Unity-related problem, I'll help you debug it, because I love debugging. And I'll see you next time when we're going to do... We actually may take this environment and train it using Python, which is another thing you can do. And, yeah, there's a couple other stable baselines projects I want to do as well. Anyways, guys, see you later.